Number 7, sketch and describe in your own words. Now, if I say in your own words, please use your own words, okay? And you cannot just skip this on your test. If you are to describe something in your own words, write something down, not just a picture, okay? I know picture may be worth thousands of words, 1,000 words, but that's not what I mean. When I say describe in your own words, use your own words to describe what you're trying to draw. The solid E described as below. Okay, so E is the solid where Z is between 7 and this. Okay, what is that? And then write a triple integral that expresses the volume of this solid using cylindrical coordinate system. Now, so what do you do when you see a problem like this? I would look at this part first. Z is equal to 16 minus basically this part. You can take the parentheses and change that into this, and that's going to be r squared, right? Hopefully you realize this is going to be an upside down paraboloid, a circular paraboloid. And then Z is cut off below by the horizontal line at height 7. So let's take a look at what it looks like. Hopefully you have gotten this right. So yeah, well, okay. So if Z is 16 minus x squared minus y squared, we're talking about a paraboloid like this. Right? And so what you do here is, when you can you can cut it at where Z is equal to 7. Okay. Now, in order to establish the upper and lower limits for R, you have to project not this whole thing, but this part. Okay. So in other words, you have this part, the solid E, to integrate. You need to know how big this circle is. Okay. So what is that when Z is equal to 7? Well, you can let Z equal to 7, which is equal to this whole expression, to find out this intersection circle. The intersection circle is x squared plus y squared is equal to 9. That's radius 3, right? So if you project this down to the xy plane, it'll just become the circle of radius 3. That is a key, okay? So now, how would you describe this? If you didn't use your own words to describe this, I'll take some points off, maybe 2, 3 points. You should say something like, and it doesn't have to be really accurate or formal. You should say it is a circular paraboloid cut off at Z is equal to 7 over the circle of radius 3. You could even say something like it looks like the head of a bullet, going flying straight up, something like that, where the radius is 3. Okay, and it looks like the height is 9, but it's you don't have to describe that much detail. Okay, at this point it should be easy to come up with your triple integral. Theta goes from 0 to 2 pi. Oh, by the way, you should always write, before you do anything else, at this point you should write r dr, sorry, r dz dr d theta. That's your dv in cylindrical coordinates. Theta goes from 0 to 2 pi, that's all the way around. R, as we said, goes from 0 to 3, because if you look at this from the top, it is going to be the radius 3 circle. And Z goes from, not from 0, right, from 7 to the point where you hit the paraboloid, which is 16 minus r squared. So that is your answer. Okay, so number 7, it says describe, right? Sketch and describe. And then write a triple integral. And it says do not evaluate. Okay, and that's what I was talking about. Don't evaluate if you are asked not to evaluate. You may be tempted to, because this is not that hard. Okay, but resist the temptation to do something extra, especially if you have a time limit, like during your exam. All right, evaluate the triple integral. Okay, so what do you have to do? That seems like a straightforward question. You don't even have to sketch this. Do you? Well, it seems like this is this is a polynomial in x, y, and z. So that should be a pretty easy one to integrate. All right, so just go ahead and do that. 6xz integrate with respect to dz will give you 3xz squared, right? Because this, if you differentiate this, you get 6xz, differentiate with respect to z. And then you plug in y and 0, and so this becomes 3xy squared minus 0, which is this. Now we integrate this with respect to y, and that becomes xy cubed. Plug in 2x and 0 for y, right? So and this is maybe the slightly tricky because 2x quantity to the third power is 8x cubed. So you have 8x cubed minus 0, and that should be multiplied by this other x. So you have x to the fourth multiplied by 8, and that's what you integrate. You get 8/5. Okay, that again, this is a straightforward integration problem. Number 9, sketch a solid whose volume is given by the following. Do not evaluate. Again, let's think about this. My eyes will immediately go to y, going from 0 to 9. Okay, and then x going from this to this, and at this point, you may want to do this, plus or minus, square both sides. Okay, that's not a circle, right? Because that y is not squared. So y is 9 minus x squared. You know what this looks like? It's an upside down parabola, and it's going like this. Okay. Now it says y goes from 0 to 9. X goes from negative of this to positive of this. So that's the entire thing, not half of it, just the entire thing, both sides, both the right and the left-hand side. And then z goes from 0 to 4. So at this point, because z is, the bounds of z are constant, you know, basically this is just this whole thing, and then just make it up 4 stories high, all right? So the picture is going to look like this. You start with this, just add the height of 4 at every single point. You have x, y, and so the picture should look like this. All right, and what do you call that? Well, since it's a parabola and you go up, it's a parabolic cylinder. It's technically not a parabolic cylinder. If you say a parabolic cylinder, you should be describing only the surface of this, right? But this is actually a solid. So the question says sketch a solid, all right, whose volume is given by that. Do not integrate. So all you have to do is to show this. You don't even have to describe it. You can say it's a parabolic. You can say this is a solid bounded by the xz plane and a parabolic cylinder with a radius with the height 4. But since you are not asked to describe it, all you have to do is to leave the sketch and you'll be okay. Make sure you show your work like this. All right, so that brings us to probably the hardest question on this practice test. If you can't do this, that's okay. Number 10 is quite hard. Rewrite the integral below in the order dy dx dz, but even before that, okay, just sketching this is not so easy. It looks innocent enough, right? There's no really difficult looking equations here or expression. Sketch the solid volume, sketch the solid whose volume is this triple integral. So here's what you have, and here's a problem you're going to encounter. Y goes from 0 to 2. That's easy enough, right? Y goes from 0 to 2. Z goes from y to 2. So z is equal to y. All right, so at this point, you have this. And here's y, z looking at, see, the thing is, this is my 3-dimensional space. This second picture here, this is the top view. This picture is like looking at this from this angle, okay? I am over here looking at it this way. And it says z goes from y to 2. So z is equal to y is this line. And z is equal to 2 is this line, right? So it's going to look like this. Okay, that's what you're seeing. And y only goes from 0 to 2. So far you have this. And then x goes from 0 to z, right? So what does that look like? Now again, this time you're going to have to look at this from this point of view. Okay, if you look at that from this point of view, then you have x, no, x and z here. Okay, over here, if you're looking from the left side of this space, x goes from 0 to z. X goes from 0 to z is equal to x. So now we're talking about this kind of thing. All right, so how do you combine this? All right, and this is the hard part. Let me just show you what I try to to demonstrate on this problem here. This is the final result of this, but remember the preliminary, so you want to have some preliminary sketches. If I started with 0, okay, y is between 0 and 2, right? So that's this thing here. And then z is between y and 2. Let me just show you what I'm saying. In this first two stages, okay, I have established this, right? And then y goes from 0 to 2. Okay, so once I have these two things here, I will just go ahead and sketch this prism because I'm just, right now, I'm not thinking about z, okay? So if you take this and stretch it in the x direction, this is what you get. Okay, so this is going to be, and let me show you what I mean by this. It's really this part here extended, right? And it may help you to just go ahead and draw this entire rectangular box. This is what I'm talking about is this whole thing, like this, okay? This big block. Think of chiseling from this block, because I know that everything is contained, everything in this problem is contained in this rectangular box. Think of this as the marble that you start your sculpture from. You know, like Michelangelo looked at the piece of marble and somehow he saw David inside. Like, what? Okay. It's not that artistic. Okay. But anyway, so you have this origin and you have this, you know, y is equal to 2. And then you cut this along here. All right. So that's what I'm talking about here. This. Okay. So you first cut it so that you'll have exactly half of this itself is hard to draw. Okay. It sort of looks like this. Okay, so that's what I'm saying. This is like your preliminary picture. So I start with a block of what 2 by 2 by whatever this length is. Okay, long. Okay, and then you just cut it along this 45-degree angle, and you get a prism. Okay, so this is a prism. It's 2 by 2, and then extended in the x direction. All right, so that's a starting point. Okay, well, that's the starting point when you have these two things. And now comes the last part, which is quite difficult to combine with the first part. X goes from 0 to z, right? So that's this thing. So the question is, how do you do that? X goes from 0 to z. X goes from 0. You know what? I kind of messed up on this picture, didn't I? X goes from 0 to z. So that is not the picture I should have had. See, I get confused here. X goes from 0 to z. So once you decide on y and z, right? So for each z, x goes from 0 to where x is equal to z, not z is equal to x. So we're talking about this part here. Okay. So that's the part I need to consider along with this prism that I just developed. So if you look at this from the three-dimensional standpoint, okay, try to draw this in this picture here. X is equal to z is this line like this over on this plane, okay? And so what we're saying is it's basically this. X goes from 0 to x is equal to z. Okay, so this is a 45-degree angle, this is a 45-degree angle, and that's what we have to deal with, right? So imagine this, and you extend it in the y direction. So that's the slice that I have to cut this other block along. So you see that this is the prism? Yeah, maybe I should draw with different color now. What would be a good color here? Maybe light orange. What I have is this prism, not prison, okay, prism, okay. And now I get to cut this along this plane. Z is equal to x. So that's this thing here extended this way. So think about this, okay? Z is equal to x. So this point here would be, what is that point? 1, 1, 0, okay? And this point is 0, 0, 0. Okay, and of course, this line or this plane will cut this solid through and then make this slice, and of course this slice. And if you have, if this plane cuts this prism at this point and this point and this point, of course it's going to have a triangular side. That's going to be the intersection of this prism and this plane. Okay, so what are these points here? This is the point. What did I say? It's 1, 0, 1. Okay, remember x is equal to z, has to be true here. This is 0, 0, 0, and this is 1, 1, 1. No, 1, 2, 1, right? Because this length is 2. So, so that's what's happening. So again, this point is 1, 0, 1. This point is 1, 2, 1. And this point is the origin. And so that would be the cross section of this prism and this plane. So the answer to this question is actually something like this, or maybe it's better seen, you know, over here. And you may want to have this entire thing like, hey, you know, this is the best I can do. It is an upside down pyramid. You can see that on the top you have a 2 by 1. It's actually a rectangular thing, right? And then you have 4 triangular sides here. And let's see, this, the length, the height is it's going to be 2. Okay, so this is a rectangular upside down pyramid, and that's what the whole thing is. So now you get to, that's not the answer, right? Because the question actually asks you to do something more difficult. Sketch the solid. I did that. Oh, is that all I have to do? Rewrite the integral below in the order of dy, dx, dz. So then I get to do that. All right, dy, dx, dz. How would you rewrite this in the order dy, dx, dz? Think of this. Z goes from what to what? I'm going to go back to green. Z goes from 0 to 2. Okay, so that part should be easy. And then x goes from what to what? All right, so for each z, if you slice it at a particular z, you will get, yeah, what do you get? Think of crossing the pyramid with a horizontal line. Okay, you are going to get a quadrilateral. In this case, it's still going to be a parallelogram, but it's a rectangle, right? And so in this rectangle, what is that? X goes from what to what? Okay, for each z. Well, it goes from 0 to something. Okay, and this something is the point. Remember, that's the point where the pyramid meets or ends at the plane z is equal to x. And the question is, what's x? Well, x is z, right? So this x goes from 0 to z. Now, the reason it starts at 0 is because it's always starting at this yz plane. Okay, imagine that, right? So x goes from 0 to z. And then for each z and x I picked, y goes from what to what? Well, y goes from this point all the way to here. So y always starts at 0, okay, because this is a part of the xz plane, until it hits this point. What is this point? Well, this point belongs to this plane, which is the first plane I cut this at. And that's, you know, that's this thing here. I'm going from here to here. So what is this plane here? That plane was y is equal to z. So y goes from 0 to z because this point is where y is equal to z. So it doesn't look bad, okay? But it takes a tremendous amount of work to go from these simple looking, you know, 0, 2, y2, 0, z, to our correct answer, 0, 2, 0, z, 0, z. Okay, this is not something you can guess. And it is much more difficult to picture than the other questions. So it is a challenging question. If you can't do this, that's okay. If you can do this, that's great. Try to practice, at least try to understand that this is the correct answer. Convince yourself, oh yeah, I guess that would work, right? Whether you can actually do a problem like this, I understand if you can't, but try your best to be able to visualize this and to understand each process of it, okay? All right, so that's what I'll ask you to do. All right, let's go to number 11. We got 2 more questions, right? And so number 11, using spherical coordinates, set up a triple integral that expresses the volume of the portion of the solid ball of radius 2. That's easy. Centered at the origin in the first octant. Oh, okay. So now they just want you to give like 1/8 of this. Okay. And then evaluate the integral. So think of, again, think of this. So this is the picture. And what you have to do is to set the bounds. Okay. So remember, you should write down all of this first. dv in spherical coordinates is r, no, not r, rho square sine phi d rho d phi d theta. Rho square sine phi d rho d phi d theta, right? So, you just write it down first. And then theta goes from, well, this doesn't go from 0 to pi over 2, 2 pi. It only goes to pi over 2 and stops because it's the first octant, right? And then phi goes from 0 to also pi over 2. So that, because, if you go all the way to pi, then you go to the bottom half of this of the sphere. And then rho goes from 0 to 2 because it's the entire solid ball of the radius 2. You only just have 1/8 of it. So that is the integral, triple integral. The integration itself is not that difficult. Our rho square always becomes 1/3 rho cubed. Plug in 2 and 0, you get 8/3, which you can bring to the front. And then the next step is to integrate sine of phi, which is negative cosine of phi. And you go from 0 to pi over 2. Remember, the cosine of pi over 2 is 0, yes. And so once you do this, oh, by the way, because I know cosine of 0 is 1, whenever I see a negative cosine, I tend to switch it because I hate negative signs. It just really, they confuse me to no end. So change that negative cosine to positive cosine, and then switch these, okay, from pi over 2 to 0. I know this is backwards, but that makes it easier because cosine of 0 is 1 and cosine of pi over 2 is 0. So this is, 1, right? And so that's an equal sign. That's not a negative sign. I didn't want to have a negative sign. That's why I switched this. All right, so this is pi over 2 times 8 over 3, and that's 4 pi over 3. Finally, number 12. Sketch a solid whose volume is this. Here is your final Jeopardy clue. What is the question? All right, so you can play that 30-second Jeopardy theme and try to figure out the answer. The answer is, what is, and you should sketch the solid because that's what you're asked to do. All right, so first it's in the cylindrical coordinates, right? And then theta goes from 0 to pi. R goes from 0 to 2. So that's over this entire semicircle. And this R is okay. You don't have to worry about that, right? Because that's the V in a cylindrical coordinate. And looks like Z goes from R to 2. Okay, so Z is equal to 2 is easy, but Z is equal to R. What is that? Well, that's the cone, right? And so it's going to be, the solid is going to be a cone because Z is equal to 2 is represented by that cone. And so it really is just, the cone, except it's only about the top hemisphere. So it's half of this cone. So this picture is correct. It's not the entire cone. You just cut this in half. So you can have the top half where theta goes from 0 to pi. Okay, again, the integration is not that that hard. Okay, so when you integrate R with respect to Z from R to 2, you just get 2 minus R. You still have an extra R here. So this is really integrating 2R minus R squared. That becomes R squared minus 1/3 R cubed. Plug in 2. And so you have 4 minus 8/3. And that's 12 over 3 minus 8 over 3. And that's 4 over 3. And you integrate that with respect to theta, and you just get 4/3 pi. Now, I wrote this here at the bottom here. That's the same thing as I wrote here. See, we should know what the volume is, okay? Because we know how to find the volume of the cone, right? This is a cone of height 2, radius 2. So it's 1/3 pi r square h, and r is 2, h is 2, and so this part will be 8/3 pi, and of course this is half of it, so it should be 4/3 pi, and so that's 8/3 pi would be the volume of the entire cone of radius 2 and height 2, and since it's half of it, this is the expected answer. All right, so that is the last question of practice test 4. Okay, so chapter 5 is almost done. If you have been following all of these sections by watching videos, all 7 sections, but in particular the first 6 sections, because section 7 will not be covered on the test. So if you have been following along and doing your homework faithfully, now you've got 2 review sheets, right? Number 1 was the review of triple integrals, and then you've had practice test 4. So you should be ready for your test 4. I hope you do well, and I will see you later. Have a great week. Take care. Bye.